Hello, and welcome to the Penrose GED prep lesson on exponents. This is the first video for the worksheet on exponents, roots, and scientific notation. The idea behind exponents is simple. If we have a number multiplied by itself a certain number of times, then we can write that string of products as an exponent. For example, 3 times 3 times 3 times 3, which is a product of 4 threes, can be written like this. We read this as 3 to the 4th power, or just 3 to the 4th. In this case, we say 3 is the base, and 4 is the exponent. Notice that the exponent, in this case 4, is just the number of times that the base appears in our original product. However, the value of the exponent can be negative. For example, we could take 3 to the negative 4th power. At first this might seem very strange, since the exponent is supposed to represent the number of terms in a product. How can we multiply 3 by itself negative 4 times? Although negative exponents sound nonsensical, they're actually quite useful. You will see why shortly. First, let's talk about basic positive whole number exponents, like 2 squared. Simplifying 2 squared is really just a matter of multiplying 2 by itself. But exponential notation can do one thing very well that our regular old products cannot. Exponential notation is useful for representing very large numbers without us having to write a whole lot. For instance, 1 million, which is 10 times itself 6 times, is written as just 10 to the 6th in exponential notation. Let's look at another example. 10 to the 10 to the 100th is a googolplex, a number that is so large there's not even enough paper in the world to write it down in decimal notation. So exponents are useful for writing big numbers. Let's look at some other properties of exponents. Notice that we can write 4 to the 4th as 4 times 4 times 4 times 4. And if we group these into two different groups of 4 times 4s, we can rewrite 4 to the 4th as 4 squared times 4 squared. Notice that the exponents on the right side of the equation here, 2 and 2, when added together equal 4. This is no accident. What I have just written is an example of a rule that applies to all exponents. The rule is this: if we have a product of two different exponents with the same base, we can simply take the sum of the exponents and combine the bases. When we write it out, it looks like this. Let's see another example of this rule. 3 squared times 3 to the 4th can be written as 3 times 3, which is the same as 3 squared, times 3 times 3 times 3 times 3, which is 3 to the 4th. Notice that if we take away the parentheses here, we just have a product of 6 threes. So we can rewrite this as 3 to the 6th. Again, on the left side of the equation, this is the same thing as adding the exponents. 3 to the 2 plus 4 equals 3 to the 6th. This rule is helpful for understanding most other properties of exponents, so please make sure you understand how it works before continuing with this video. Good. Let's examine another scenario. How do we evaluate a number to the 1st power? Let's consider the example of 8 squared. 8 squared is 8 times 8. There are two 8's in this product, corresponding to the 2 in the exponent. So 8 to the 1st power is just 8, without any product. In fact, any other number to the 1st power is just that number itself. Please pause the video now and take the time to write this out on the first line in the box at the top of section 1 on your worksheet. Also make sure that this makes sense to you. So far, we have seen how to combine exponents with the same base and how to take numbers to the first power. We are now ready to understand how to think about and use negative exponents. If you have not yet learned how to simplify equations, do not worry about the next explanation I am about to give. Just make sure you understand the result. Since addition in the exponent means we multiply, if we subtract in the exponent, we are really multiplying by a number to the negative power. For example, 3 to the first equals 3 to the 2 minus 1, which is just 1, which we can rewrite as 3 squared times 3 to the negative first power. Let's rewrite this below for clarity. 3 squared times 3 to the negative first is 3 to the first, which is just 3. If we want to solve this equation for 3 to the negative first, we can divide both sides by 3 squared. This gives us 3 to the negative first is equal to 3 divided by 3 squared, which we can simplify. Thus we have shown that 3 to the minus first is equal to 1/3. Notice that this can be rewritten as 1 over 3 to the first. I will explain why this is important in a second. Now that we know that 3 to the minus first is 1/3, we can solve for 3 to the minus second. 3 to the minus 2 can be rewritten as 3 to the minus 1 minus 1, which equals 3 to the minus first times 3 to the minus first, which by the above result equals 1/3 times 1/3, or 1/9. Notice that 1/9 is actually 1 over 3 squared. Do you notice a pattern? If you were to say that 3 to the minus third is 1 over 3 to the third, you would be correct. We can keep multiplying by 3 to the minus first to get lower and lower powers of 3. So on and so forth. Of course, we can replace 3 with any base we like, so we now know how to take negative exponents. The general rule is, any number to a negative exponent equals 1 divided by that number to the same exponent but positive. You may also want to write an example like this one to help you remember how to take negative exponents in the space provided on your worksheet. Please pause the video again and take the time to write out this rule for negative exponents and to understand how it works. There is one scenario we have not yet covered. Say we wanted to take a number to the 0th power, say 4 to the 0. How do we go about doing that? Well, we already have all the tools we need at our disposal. Let's rewrite 4 to the 0 as 4 to the 1 minus 1. Of course, 1 minus 1 is just 0, so this is okay. We can do this. Applying the first rule we learned, we can rewrite 4 to the 1 minus 1 as 4 to the first power times 4 to the minus first power, which is equal to 4 times 1/4, which equals 4 over 4, or 1. So 4 to the 0th power equals 1. In fact, any number to the 0th power is still 1. This is the third and final useful fact of exponents that I would recommend you write on your worksheet before starting the problems. You should now work through the problems in section 1 on your worksheet. It In the next video, we will work through solutions to the starter problems for this section.